Tonight, an alien observatory could flag Earth as a living-looking world. Notice a hint of technology and decide we are not worth contacting. That possibility feels insulting for about half a second. Then it becomes oddly reassuring. Being ignored would at least mean someone is out there. Our first instinct is simple if another civilization discovered intelligent life. Surely it would make contact. We know what that discovery would do to us. Every telescope would turn toward it. Governments, scientists, and ordinary people would all want an answer. So why would aliens react differently? Because detecting Earth, recognizing technology, understanding intelligence, and choosing to communicate are 4 separate steps. The silence above us does not tell us which step failed. It may not even tell us that anyone started. So the investigation is not merely whether aliens could see Earth, it is whether they could see enough to recognize humanity, and whether science gives us any reason to think they would care. The most famous way to make aliens look overwhelmingly advanced begins with Nikolai Kardashev. In 1964, he classified technological civilizations by the power available to them. A Type II civilization would operate at roughly the power scale of its star.
That sounds like a ranking of cosmic intelligence.
It is not. The Kardashev Scale is closer to the wattage label on a machine than an intelligence test for the civilization that built it. It can compare power budgets. It cannot measure curiosity, compassion, ethics, efficiency, fear, scientific priorities, or willingness to answer a message. Even the familiar claim that humanity is around type 0.73 needs care. Kardashev's original system used 3 large categories. The decimal markings between them came later through a continuous formula associated with Carl Sagan in 1973. Under that version, humanity does land at roughly 0.73. But that number is a position on a logarithmic power scale, not a progress bar showing that we are 73% finished becoming type 1. On the Alien Observatory's information card, 0.73 might appear beside Earth. It looks precise. It feels like a grade. It is only an energy reading. Humanity's total energy supply is just over 600 exajoules per year, averaged across the year. That is roughly 19 trillion watts flowing through the global energy system. Now place that beside the nominal luminosity of the Sun, 3.828 times 10 to the 26 watts. A sun-scale power supply is around 20 trillion times humanity's present average. That is the scale shock. If all of humanity's current energy use were compressed into 1 second, 1 second of sun-scale power would correspond to roughly 640,000 years at our rate. The comparison does not tell us how efficiently either civilization uses energy. It does not tell us what either one values, but physically the gap is enormous. This is where the ant analogy becomes tempting. Beside a civilization controlling stellar scale power, our cities, satellites, and radio systems might look tiny. We imagine Earth entering an alien database beside millions of worlds, receiving a tiny 0.73 marker, and being pushed to the bottom of the queue. Maybe, but no known alien civilization has been placed anywhere on this scale. We have not confirmed that Type II societies exist, and even if one did, the scale would tell us how much power it could command, not what would capture its attention. The next clue weakens the analogy further. Aliens may not need anything close to Type II power to notice us. In 2025, Sophia Sheikh and her colleagues modeled a revealing test Earth trying to detect a duplicate Earth using present-day or near-term instruments. Instead of asking what magical alien technology might do, they asked how visible our own technology would be to something roughly comparable. The answer depends dramatically on which signal is being observed. Under the study's assumptions, powerful planetary radar could theoretically be detectable from about 12,000 light-years away. Deep Space Network transmissions reached a modeled distance of about 65 light-years. LTE radio leakage fell to roughly 4 light-years. Voyager-like transmissions did not reach even 1 light-year in the same sense. Earth is not a lighthouse shining evenly in every direction. It is more like a dark building that occasionally sweeps a powerful flashlight beam across one narrow part of the sky. Our loudest clue is not a permanent glow surrounding the planet. Planetary radar is intermittent and directed. An observer must be in the right direction, looking at the right time, with the right instrument. The same hierarchy overturns another popular image. From another star, aliens would not see Earth's continents sparkling with city lights. In the model, present Earth-like city lights were far too faint to detect from another star. An industrial nitrogen dioxide signature might be detectable from around 5.7 light-years under favorable assumptions. Even that would require interpretation and supporting evidence. So, a civilization with Earth-level technology could potentially detect certain human signals. Type 2 power is not the minimum admission price. The Earth card changes. The giant stellar energy symbol no longer answers the question. The card now needs separate lines for signal type, distance, direction, duration, and sensitivity. And that creates a geometry problem. Lisa Kaltenegger and Jackie Faraday used Gaia stellar data to identify stars positioned to watch Earth cross the Sun. A transit is like a tiny insect moving across a distant lamp. The insect is visible only to observers standing along a narrow corridor. Over the previous 5,000 years, 1,715 stars within about 326 light-years occupied positions from which Earth could be seen transiting the Sun. Another 319 will enter that viewing zone during the next 5,000 years. By 2021, human-made radio waves had passed 75 of the nearest stars in that set. That sounds like 75 opportunities for somebody to notice us. But the clues are not equal. A transit can reveal that Earth exists and allow observers to study its atmosphere. It does not automatically reveal cities, machines, or intelligent life. Radio energy passing a star does not guarantee that anyone was listening, that the signal was strong enough, or that it looked engineered rather than natural noise. The alien information card might first show only a blue dot crossing a star. Atmospheric evidence could add possible life, a rare. Directed radar pulse might briefly add possible technology. None of those labels says humanity confirmed. Now, distance changes the entire investigation. Electromagnetic information travels at the speed of light. A civilization 100 light-years away receives Earth roughly 100 years late. Its telescope is not showing our present. It is playing an old recording whose age is set by distance. This is where the simple story breaks. A modeled detection range of 12,000 light-years does not mean our strongest radar has already reached observers 12,000 light-years away. Those radar systems have existed for far less than 12,000 years. The signal cannot be detected somewhere it has not yet arrived. One observer might see an Earth before modern industry. Another might receive early radio leakage but miss a narrow radar beam. A nearer observer could catch one suspicious pulse and never see it repeat. Each observer gets a different historical version of us. The question is no longer whether powerful aliens can see primitive humans. It is whether detection, recognition, timing, and attention ever overlap at all. First, Earth must lie within useful range. Then the observer needs the correct geometry, wavelength, sensitivity, and observation time. The signal must point toward that observer and arrive while the observer is watching. The observer must separate an engineered clue from natural background, connect it to Earth, and infer that a technological civilization produced it. Only then does our original emotional question even begin. Would they contact us? In 1973, astronomer John A. Ball published the zoo hypothesis, suggesting that advanced extraterrestrial civilizations might deliberately observe humanity without interfering. The idea resembles researchers watching wildlife while trying not to alter its behavior. It is a legitimate published speculation, not evidence that anyone is watching. The ant analogy has the same weakness. Humans do not have one universal relationship with ants. We ignore many, we study some, we protect certain colonies, we destroy others accidentally. Some people build entire careers around understanding tiny organisms that possess no power remotely comparable to ours. Physical superiority does not produce one predictable motive, even in humans. Why should an energy scale reveal the psychology of an unknown species? An observer might value non-interference. It might fear revealing its location. It might prefer centuries of study before acting. It might consider communication inefficient, unsafe, or simply unimportant. Its idea of communication might not resemble ours at all.
Every one of those motives is conceivable.
None is confirmed, and a missing reply has many explanations that require no deliberate rejection. The observer may be too far away. The signal may have missed it. It may have watched at the wrong frequency or time. It may have failed to recognize the clue. It may be unable to answer. It may no longer exist. Or there may be no observer. Our own search cannot separate those possibilities yet. Quantitative studies of radio SETI coverage have compared the portion examined to something closer to a large hot tub or small swimming pool against all of Earth's oceans. The comparison represents a multidimensional search space sky position. Frequency, strength, repetition, timing, and other variables, not a literal volume of space. Still, the lesson is brutal. Lowering one bucket into an ocean, finding no whale inside it, and declaring the ocean empty would be absurd. Scientists seriously search for radio and laser pulses, artificial atmospheric chemicals, city lights, and other possible technosignatures. No extraterrestrial technosignature has been confirmed. That fact forces the imagined alien out of the control room. We can estimate whether some Earth signals are detectable. We can identify stars with privileged viewing geometry. We can calculate when our emissions reach them. We can describe what evidence might suggest life or technology. But silence contains almost no reliable information about the psychology of an unseen observer. Return to tonight's alien observatory. Earth appears as a small blue world with incomplete clues. The display might read, "Possible life." A brief signal might add, "Possible technology." A cursor could hover over, "Contact." The observer could open the file, archive it, study it for centuries, avoid it, or never receive it at all. Then the observatory fades. Because science has never established that it exists, aliens could potentially detect Earth without contacting humanity. A much more capable civilization could possibly monitor us while remaining invisible to our present searches. Physics does not require contact after detection. But the claim that aliens have seen us and decided we are too primitive, too boring, or too unimportant is still speculation about a mind we have never observed. The universe has not delivered a verdict on humanity's importance. Before deciding that we have been ignored, we first need evidence that anyone was watching.